Okay, so here's Desmos, and all I want you to do with this video is just to be able to use it, rewind it, look at it, and understand how to use Desmos to create the end product for your project. So right now we just have an absolute value equation which creates a V. And our vertex on that absolute value is actually at -3, comma -4. And we can tell that from the equation because your vertex is, remember this equation is A, absolute value of x minus h plus k. And so we can tell that the vertex has to be a -3 because that's your h, and a -4 because that's your k. So we know how to place this. We also see that it's been stretched by 2. So it goes over 1 and up 2, over 1, up 2, in order to create this V. So I have a thinner V than I would if I didn't have a 2 in there. If I just got rid of that 2, it would be much wider. So here we have a blue line that actually has no stretch to it, and so that would be the normal size of an absolute value. Okay, and remember, if we put a negative there, it would flip it upside down, and all of those things that we learned in class. So you have to recognize all of those features in order to place your V in the right location, as well as to make it the size that you wanted. So now let's assume that we didn't like the location of this blue V. Let's assume that we wanted it to be over here somewhere for whatever reason. I don't know what you would be creating, but let's see about moving it over here. Well, to move an absolute value, you have to move the vertex. So you have to decide what it is that you want for your vertex point. And so I want it to be at this location here. So that location is 3, -2. So I'm going to change this blue equation to be to put the vertex over here. Okay, so you can see that the blue line has moved, and because I wanted it to be in this new location. And so I had changed the equation. Remember, it used to be x plus 3, absolute value of x plus 3 minus 4. And so I just changed it to be a -3 so that it would move over to the positive side of the axis. Because remember, the equation is x minus h. Now my h is a +3. And plus k, and my k is a -2, and that's what gives me my vertex. So I just moved it. Okay, so that's fine. Now our V's are in the right location, but they're so long. The legs are so long. I don't want them that big. I want this one to just look like a little check mark. So like I want it to stop right here and just do a check mark like that. That's all I want. Well, if that's all I want, then I need to notice that I need it to stop right here on the x-axis. So on the x-axis, I want it to go from here and greater. So I want to get rid of all of this line here. So that means that my lowest value of x is going to be -3.5. Okay, so I'm going to limit my domain to be -3.5, and I want it to stop here at this point, and that's going to be 0. So I'm going to put a limitation on my red line to say that -3.5 is less than or equal to x, which is less than or equal to 0. And so the only part of my graph that will show will be between x equals -3.5 to x equals 0. So just in this region, that's the only thing that's going to show up. Okay, so now you'll notice that I added this extra little piece here on my equation so that it would show the restriction that I gave it. And sure enough, that's the only part of my V that is showing. Now, what I've noticed several of you trying to do is once you've restricted it, you decide, oh, well, I really don't like the location. I want to move it over here just a little bit. And so then you move it over and it doesn't look like what you were expecting. Well, that's because your restrictions stayed in the same spot. So I'm going to do that. I'm just going to take this red V and I'm going to move it over 1 unit over, and it totally messes up what I think I'm going to get. And that's going to happen if you don't pay attention to all of the information that you've given it for this red line. So the restrictions as well as the equation have to be moved. Okay, so now you'll see that I've moved the vertex, but boy, it doesn't look like I moved the vertex. Look, I don't have a vertex anymore. I moved it in my equation. I made it, instead of a +3, I made it a +4, which meant that my vertex was supposed to be here, but there's nothing even there. Well, why is that? Well, it's because I still left my restrictions the same. I still stopped it at -3, so there's no more line that goes down here and continues on. So if that's what's happening to you, you have to remember to manipulate your restrictions as well. So that's what I need to do. I need to make my restrictions. I want my little check mark. So therefore I want it needs to be restricted now to -4.5. And as soon as I make that update to my restriction, notice that when I change it to -4.5, I get my check mark back exactly the way I want it. And now if I didn't want it that long, I could reduce the limitation. I could stop my my x value at -2 so that I just have this little check mark. Okay, so however you want to restrict your drawing, and of course that's why you wanted to have it drawn on a piece of graph paper first so that you could tell where each item was going to be. Okay, and so now I've limited my blue line so that I get a backwards check mark from there. Again, it doesn't really matter how you limit things, or it really just depends on what you want your drawing to look like. Now, a lot of you are having difficulties as well doing your shading because a lot of you have decided you wanted to do this really complicated drawing. And so you're trying to do all of this nice little shading, and that's not the intent here because the shading can be really frustrating. But recognize that just to shade anything, you're just going to use inequalities. But you have to have some kind of boundary to your inequality, otherwise the entire graph is going to get shaded. So here you can see that I've put an inequality in, but notice that one, I had to change it. I can't use function notation with an inequality. You have to change it to y, and that's fine. I don't even want to go to that explanation, but realize you have to change it to be y, not a function notation. So, so y is less than this line, but then a lot of people complain, well, look, it's dashed. I don't want it to be dashed. I want it to be solid. Well, then make it less than or equal to. So remember, it still follows that same convention of what we said before. So now it's shaded less than this line. Yep, indeed. But you're like, but I didn't want it to shade over here. Well, you didn't restrict it to not shade over there. If you need it to stop at this line, then you have to restrict it to that line. If you want it to stop down here at this point, then you need to restrict it. If you want it to stop here, the shading that is, then you need to restrict it. All of those kinds of things are just simply adding more restrictions into your explanation of what you want the blue to do. Okay, so now you should probably notice that I had to do a bit of manipulation in order to get the shading the way I wanted it to, and that's what's going to end up happening. You have to be able to look at the graph and understand what are the restrictions doing, what are your equations doing. And so sometimes it takes a little bit more thought than just simply throwing some numbers out there. So you want to really recognize what's happening in your equation or in your explanation of what you want the color to do. So you'll notice that this entire thing here identifies all of the different restrictions. And so with all of those restrictions identified, it helps to limit where the shading is. But notice that I put this extra green line here. If I didn't put that green line, then all of these shading restrictions would have cut off the blue line that was here and over here. So I needed to preserve that line because I still wanted that backwards check mark. I just wanted all of the shading to be identified right here. So all of my restrictions were for my shading, and then I put this extra indicator of this green line, which I will turn to blue because I don't want it to be green. I really wanted it to be blue. I left it green so that you can see that I had to put another line. It's the exact same line as this line. Notice the equation is the same, but this defines all the shading. And this defines the line that I want drawn because the line and the shading do not have the same limitations. Okay, so sometimes you have to do those things. All right, so changing the color, I've shown you that before. You just hold on to that button and it'll give you the color palette and then you can change it to blue. So I want to move on to doing a circle because I still think a few of you are confused with your circles. Okay, so here's your circle, and notice I have a vertex on this circle of the vertex is right in the middle of the circle. This vertex is the point -7, 4. And I put the vertex on my graph just so that you could see it. So I indicated a point of -7, 4, just so that I could see it here. You wouldn't necessarily have to have that on your graph. I just did it for explanation purposes because I want you to see where that center is. That center, this is still h, k. And so our circle equation is a little different than our absolute value or our quadratic equations as far as vertex are concerned, but the h and the k still indicate our x and y value at some point in our circle, and for the circle it's always the center point. Okay, so my 7 is, or excuse me, it's a -7 because the equation of a circle is y minus k squared plus x minus h squared equals the radius squared. And here on my radius, notice my radius is 3, and 3 squared is 9. Okay, so we have this, here's my h, and it goes with my x value, x minus h, and minus a -7 gives me a +7. Here I have y minus k, my k is 4, and so that's where that center point comes in, is being able to put your circle where you want it, because the center of the circle defines its location on the graph. So wherever you want it, that's where you put it. If you want a skinnier or a tinier circle, then you would make the 9 smaller. If you wanted a larger circle, you'd make it bigger. If you wanted it filled in, you'd change the equal sign to an inequality. So all of those different features allow you to make your circle look different. Okay, so now I just want to show you the oval real quick. So you can see that I've shaded it by putting an inequality there, and also I've made it longer along the y-axis by putting a multiplier, a compression factor out here. So whichever axis you want it to change along, you can put some kind of multiplier out there. And so ovals are just the circle equations. It's the same exact thing. Again, I have my center point. I've located it appropriately in my equation, and I simply added a multiplier. All right, so that should take care of it, and good luck with your project.